Hello everyone, we are from Community with Science Academy and this is our project. Climate change. Most people would agree that it is one of the most world-threatening problems and we need to take a look at its real cause to fix what is currently happening. Precisely, it is how we get the energy that we use in our daily lives that is the root of this problem. As our population exponentially increases, our demand in energy goes with it. And our current main source of energy? Right, it is fossil fuels that we dig up from the ground. These sources are used because of its high energy output rate, but these are carbons that are not normally in the natural carbon cycle and are being added to the cycle, causing a substantial increase in carbon dioxide gas. The gas then captures the heat that should be released back to Earth, increasing its temperature and cause catastrophic phenomena such as droughts, floods, storms, essentially climate change. Our research aims to turn the carbon dioxide gas back to usable energy, recycling the carbon. The process will use electricity, which can come from the clean sources such as solar and wind, turning these low energy output sources to fuels which can be used to power machines and cars. To achieve this process, we chose activated carbon, which can capture carbon dioxide gas to be our electrocatalyst. When powered by electricity, this electrocatalyst will drive the reaction, turning the gas into fuels such as carbon monoxide, methane, etc. Also, we selected the source of carbon to be water hyacinth because of its low cost and the additional benefit of fixing the water pollution problems caused by the plant. Now begins the process of turning the plants into the desired catalyst. First, the plant is processed into powder by cutting, drying, and blending. Then we use a technique called radiolysis, which is using gamma radiation from cobalt-60 to break up the structure and increases the surface area of the activated carbon. After that, the powder is hydrothermally heated, the process which utilizes water pressure when heated to create even more surface area. The powder is then put through an important step, which is carbonization, turning it into pure carbon. This pure carbon black is doped with nickel nitrate, which is metal that when implanted on the carbon surface will enhance its ability to capture CO2. The doped carbon is activated using potassium hydroxide, and after washing with acid, we will get our resulting electrocatalyst. Next is the result. We characterize our product using various methods. First is using scanning electron microscope to see the structure, and indeed, the product can be seen as having highest number of pores and surface area. Also with shining nickel particles on its surface. The product is also compared with the non-radialized version, which we can see that there are less amount of nickel on its surface. The X-ray diffraction of the product shows that even after carbonization, the product still retains some crystalline structure, as seen from the peak at 30 degrees. Still, it is more amorphous than non-radialized version, with generally less peaks. BET, however, shows a different story. The surface of the catalyst is measured by BET to be only 2 meters squared per gram, which is way less than even normal carbon. And so, we hypothesized that this anomaly might be from not properly drying the sample before characterization. Lastly, our cyclic voltammetry measures the capability of the electrode, which is constructed by putting the catalyst onto nickel foam. It can be concluded from the graph that the radialized version worked better than non-radialized version. Also, the peak of the graph corresponds to the voltage of negative 0.24 volts, which we hypothesized from the standard cell potential, that is the methane production reaction. From what I have said, the process that is used in the project can produce better catalysts, that is capable of producing energy that can be contained and used. Not only that, The material used is also environment friendly. This innovation will be able to provide alternative energy, which is essentially carbon footprint free, while still be able to use carbon-based fuel to feed machines or cars that may not be able to use electricity. This is what we aim to contribute on solving climate change, creating an innovation that would ease us into eventually a carbon footprint free world. Thank you for watching.